boys and girls. It's Mrs. Minion back again with two truths and a lie. And right now we're going to read about mighty mollusks. Behold the lowly limpet. Sure, the small species of sea snail known as Patella vulgata may not look like much. It doesn't seem to do very much either. But this mighty mollusk, better known as the common European limpet, has some terrifically tough teeth. And here we learn that the word mollusk is a classification of animals with soft bodies and usually hard shells, such as snails, clams, and squid. And in fact, there is a picture. Oops, I always get going the wrong way here. There is a picture of the limpet. And so we just learned that the European limpet has some terrifically tough teeth. And those little limpet teeth might someday help us build stronger race car bodies, bridges, rocket ships, and more. How, you might ask? Well, a limpet eats by dragging its radula over the tops of rocks, and its hundreds of tiny teeth scrape off the algae and diatoms that grow there. And here we learn that radula, so it scrapes its radula across, and a radula is a tough tongue-like band with teeth. So kind of like having teeth in your tongue and you just lick everything. And it scrapes off algae and diatoms. Diatoms are small floating algae common in fresh and salt water that have cell walls made of silica. Limpet teeth must be able to withstand the super scratchy surface of rocks without breaking off or wearing down too much. In other words, they have to be strong. Professor Asa Barber of the University of Portsmouth has been studying these seemingly simple creatures, and he recently made a startling discovery. Those little limpet teeth are not just strong. They're actually the strongest biological material ever discovered. That's kind of cool. Barber started looking at tensile strength, which is a measure of how much force is needed to pull something apart until it breaks. And he found that limpet teeth have a tensile strength of 6.5 gigapascals. And over here, we learned that a gigapascal is 1 million pascals, which is a standard unit of measurement for pressure. Because remember, they're testing it by pulling it apart until it breaks. So, limpet teeth have a tensile strength of 6.5 gigapascals, which is about the same as the strongest carbon fibers ever made by humans. That's really strong. Spider silk, which was previously thought to be the strongest natural material in the world, in fact, I thought spider silk was the strongest material, has a tensile strength of 4.5 gigapascals. So you can see that's a big difference. So 4.5 for spider webs, spider silk, and 6.5 for limpet teeth. That's crazy. For comparison, Kevlar, which is the synthetic material used to make bulletproof body armor. So when police officers wear bulletproof vests, they're made of a material called Kevlar. That's only 3 to 3.5 gigapascals. And human teeth, not even close. Barber wanted to know what makes limpet teeth so strong, and he discovered they're made of a composite material, which is a substance made up of 2 or more ingredients with specifically different physical or chemical properties. Each limpet tooth has an internal framework made of chitin. And here, we have to turn back a page here, bear with me. We learn that chitin is the hard substance that makes up the shells of many insects and crustaceans. So it's made of stuff that shells are made of, which has closely packed nanofibers and microscopic strands of hard iron oxide material known as geothite. We're learning all kinds of new words today. Geothite is a common brown mineral that's the main component of many types of rust. Oh, so that's kind of cool. So what they're saying is these limpet teeth are made of the same material that shells are made of and a little bit of rust. That fills in the framework. Together, the chitin and the geothite are what gives the limpet teeth their amazing strength. It also gives them another very interesting quality. Unlike most structures, limpet teeth seem to be just as strong no matter what their size. Generally, a big structure has lots of flaws and can break more easily than a smaller structure, which has fewer flaws and is stronger. Barber says, Barber says, but limpet teeth seem to break this rule. The diameter, which means how big it is around, the diameter of the nanofibers seems to be small enough that the flaws just don't matter. So large structures made from them can be every bit as strong as small ones. That's kind of cool. Now scientists can start copying limpet teeth to create new and better materials for building and manufacturing. Imagine one day you could go to the dentist and get a cavity filled, and the material your filling is made up mimics that of a limpet tooth. Chewing on rocks, however, would still not be recommended. I hope you enjoyed it. Have a great day.